In this video, we're going to see why it is that when you consider this function, this whole series equals this thing here. So by considering this function, we can see that this whole series equals this thing here. Note that minus minus and then plus plus, minus minus plus plus, minus minus plus plus. So that's the pattern. So by considering this, we can see why this will equal this. So let's start by turning this into a series. So hang on. So start by looking at this. So this thing here, we are going to make use of this because you've got a plus here and a plus here. So imagine this as being a bubble, and it's going to be x squared. So you've got to put it into this thing here. So it will be x squared to the power of n. So that will then take you to here. So that will be so this thing here. So this thing here will then be this. So this block here becomes this. And then when you look at this, consider it like this. Visualize it like this. So now it will be the same thing. It will be the same thing as over here. But then you've got times x. So this thing becomes this block. This block here becomes this block. So now it's just a matter of tidying this up. So it's blah blah blah, tidy up. That will then take you to here. That will then take you to here. And then, hang on, bear with me. And then when n equals 0, this will be 1. This will be this when n equals 0, this thing here will be 0, so it'll be x to the power of 0, which will be 1. And when n equals 0, this thing here will be x. So when n equals 0, this whole thing here will be this. When n equals 1, this whole thing here will be this. And then when n equals 2, this thing here will be this, and so on. So that will then take you to here. So earlier we started out with this, turn into a series. That will then give you this. Okay, so now we started out by considering. Let's consider this function. Well, turn into a series. That will then give you this. Okay, so now well, going back to here, so currently we are here. Well, when we turn into a series, going back to here, we require x to be strictly less than 1. So in order for you to turn this into a series, we require x to be strictly less than 1. Bear that in mind. So hang on. So going back to here, to turn this into a series, that will then take us to here. So now integrate both sides from 0 to 1, and then integrate this from 0 to 1. So integrating this will then give you this. I'm assuming you know how to integrate this. And then to integrate this, notice that remember in the past I've always asked you to keep an eye out for something being the exact derivative of another thing, or the numerator is the exact derivative of this. So when you integrate it, it will become this thing here, absolute, and then a half, because, well, think about it, and then but then we are in the realm of well, this is always positive, so you don't need the absolute. Well, integrate this, that will then give you this. Integrate this, that will then give you this, and then now integrate everything here. That will then give you this. So evaluate it from 0 to 1. So put it into here. So that will, well, evaluate this whole thing. If you put 0 into here, that will be 0. Put 0 into here, that will be 0. This will be 0. Put 0 into here, it will be 0. So really, this whole thing here becomes this. Now, in order for us to turn this into a series, we require absolute value of x to be strictly less than 1. But then we are evaluating it better than 1. If you feel uncomfortable about this, then bear with me, then integrate it from, so if you feel uncomfortable about integrating it to 1, then integrate it from 0 to b, and so when you integrate it from 0 to b, that will then give you this, and then take the limit as b heads towards 1, which will lead you to the same thing. So this is going to be 1, 1, 1, 1, 1, and so on. So going back to here, bear with me. Going back to here. So going back to here. So we started out with a function. Let's consider this function. Turn into a series, and then that will then take us to here. Integrate both sides. So you integrating this, that will then give you this. Integrate this, that will then give you this. Evaluate it from 0 to 1. This whole thing here will then become this. And then evaluate it from 0 to 1. That will then give you this. So our series here, this series here, actually turns out to be this. And by the way, this series here will actually converge because we've seen this before. Bear with me. Let me just move it across. So we've seen this. Well, this series here will converge because if you visualize a series as this, if you visualize this as being, bear with me. If you visualize this series as this one thing, and then take away another thing plus another thing. So visualize this whole thing here as this. Visualize it as this. So you've got one thing, take away another thing, plus another thing, take away another thing, plus another thing. You've got an alternating series in a way. You've got an alternating series, and then we've seen this in the past. It's an alternating series, and UN is always positive. It is non-increasing, and then it's heading towards 0. So you know the series will converge. And by the way, if you're not convinced that that this will be smaller than this, then consider this. Imagine this as being 1 over a. Imagine this as this. Well, this thing here will be 2 higher than this. So it will be a plus 2, and this thing here will be 2 more. This 6 here will be 2 more than the b. So it will be this. And then merge the two fractions together. That will then give you this. Merge these two together. That will then give you this. The 2 will cancel out. So now, if you look at the numerator are exactly the same. B minus a, b minus a. But then the denominator, bear in mind that a and b are always positive, and b is bigger than a. Then the denominator is bigger than this. Therefore, it will be smaller than this. Think about it. Well, the overall, this series here will converge because all three have been satisfied. And I'm assuming you can check these because we've done this many times in the past. Okay. So overall, this series, if you sum up this series all the way to infinity, it equals this. Okay.